In the name of God, hello dear students of grade 7. My name is Masoud. I'm a science teacher. Welcome to Thinkable Physics. This is my YouTube channel. We are going to start the chapter 6. The first section of chapter 6 is 3 states of matter. Actually, this chapter 6, consists of 3 sections. And this first section, it's our subject. The title is 3 states of matter. Let me remind you about the states of matter. In general, there are 3 states of matter. And in reality, we have 4 states of matter, but our concentration in this lecture is on 3 states, not on plasma. Right? We just define plasma and give some example of the plasma, but our concentration especially is on solid, liquid, and gas, right? And I can define a state of matter as a physical form of substance. It's a physical form in which substance exists. The procedure of my explanation is concentrating on important information. For example, I read the subject, I read the whole text, and I underline the important information, and I want you to bring your science book in front of yourself and be with me to the end of this lecture. Let's start this section. As I told you, the title of section is 3 states of matter. Let me read the first information. Let's start. Let me read it. The three most familiar states of matter are solid, liquid, and gas. You know this information. It's the background for you. Let me highlight it for you, and I want you to highlight it with me, right? You see? This is the first line. 3 states of matter: solid, liquid, and gas. The states of matter refer to the physical form in which a substance can exist. This is the definition of a state: physical form in which a substance exists. From here, the physical form in which substance can exist. This is the definition of state. For example, water commonly exists in 3 states. Water itself, in nature, exists in 3 states. What are these? Let me underline for you. Water commonly exists in 3 states: solid, liquid, and gas. Right? So solid water means ice. Solid water means ice. Liquid water means ordinary water that you drink it every day. And gas water means steam or water vapor. Right? As shown in the figure, so we have these 3 states of water in our textbook in 3 figures. Let me actually show you this figure. I'm gonna show this figure. So these figures talk about what? Talk about 3 states of water. Firstly, solid state of water. This is an iceberg or ice. Liquid state is for example, the figure shows a cascade or waterfall. And gas state, it shows us the cloud, which refers to the what? Which refers to the gas state of water. So ice or solid water, liquid water, and we have gas water, water vapor, or steam. Right. Let's complete our information. It says, in nature, matter is most commonly formed in 3 states: solid, liquid and gas. I underlined it for you. It doesn't need to repeat. These states of matter can change by altering the temperature and pressure. Very important information. I want you to focus on this information. Let me highlight it for you. The state of matter can change. So state of matter is changed by two factors: altering temperature and altering pressure, right? So you can change the state of matter from one form to another, from one state to another, by two factors. What are these factors? Altering temperature. Altering means changing temperature. Altering temperature means changing temperature, or altering pressure, changing pressure. Let me actually number it for you. Yeah. So this one, let me change the color. Changing or altering temperature, right? Altering number one, altering pressure number two. You know what the actually altering temperature is? Let me give you an example of changing temperature. For example, if you grab a pan of water and put it above the gas burner, it turns to do what? It turns to the, actually after a while, after a, for example, 50, after a while, after 10 minutes, after 20 minutes, the water above the burner, above the stove, turns to do what? Turns to the steam, turns to the water vapor. By means of what? By means of changing of temperature of the water. So temperature of water gradually rises and rises, and eventually the water turns to the steam or turns to the water vapor. This is the first actually factor, changing temperature. What do you say about the changing pressure? It's very easy. I'm gonna make it easy for you. For example, if I give you this glass of water and I want you to put it inside the refrigerator, what happens to the glass of water? Everyone knows this, the answer. The water actually turns to the ice. So liquid water turns to the solid water, turns to the ice by means of what? By means of change in temperature of the what? Of the water. Inside the refrigerator, the pressure is very high. So this high pressure affects the state of actually water. This high pressure changes the liquid water into the ice. So this is the actually changing pressure. So keep in mind that phase of matter is changed by two factors. What are these? Altering temperature and altering pressure, right? And this is about the this information. Another state of matter is plasma. So beside solid, liquid, and gas, we have one more state which is called plasma. Let me underline it for you. So plasma, another state of matter is plasma. Plasma is the fourth state of matter and is produced by what? Is produced by extremely high temperatures. Is produced by extremely high temperatures. Keep in mind that when gases temperature actually increases to do what? Increases to the thousands of Celsius of temperature, the gas is no longer gas. The gas turns to the plasma. So I can say plasma is a very actually hot gas, extremely hot gas is called plasma. Such as what? Such as lightning in the atmosphere. Lightning. You're right. You know what lightning is? Thunderstorm consists of two parts. It consists of thunderbolt, which is a roaring of the sky. It's not our subject. We don't want to concentrate on the thunderbolt, actually, or sound of the sound. We concentrate on lightning, because lightning is an example of plasma. Let me actually draw it for you. This is lightning. I'm going to change the color. This is the lightning, right? Lightning from the sky. And this lightning can actually includes infinite numbers of charges, infinite number of charge actually together make a lightning. So lightning is one example of plasma. This is the number one. Number two, the flame of fire, or I can say fire, number two, and the core of the sun and stars. So suns and stars, number three. Let me highlight them by red, actually color. So the flame of fire, number two, and the cores of the sun and the stars, because sun is our star. We belong to sun, and it's not just for sun. Any star consists of plasma, because the temperature, you know that the temperature of the stars actually reach what temperatures of a star reach millions of Celsius. For example, our sun is an ordinary star. The temperature of atmosphere of the sun, which is an ordinary star, sun, it's not a very hot, it's neither hot star nor cold star actually, right? It's a normal in temperature, normal in size, and we belong to it, right? So temperature of the atmosphere of the sun is actually 5500 Celsius. I mean 5500 Celsius. But what do you say about the temperature of the core of the sun? It reaches 15,500,000 Celsius. 15 million. That's why in these actually hot temperatures, plasma is produced. The gas automatically turns to the plasma, and actually the gas is no longer gas, right? So we have the figure of the ice, water, and steam. I explained it for you. That's it for actually. This is an introduction. Let's say introduction of the state of matter in general. Right. So here we have one more title refers to the what? Refers to our subject. Particles of matter. This is our title, particles of matter. The second subject. Matter is made up of tiny particles called atoms and molecules. So we have two more expressions. What are these expressions? Atoms and molecules. So it says matter is made up of atoms and molecules. So what are atoms and molecules? They are tiny particles. So they are tiny particles called atoms and molecules. This is the first information, right? It said these particles are too small to see without a very powerful microscope. It means atoms and molecules are invisible. You cannot observe them with your naked eyes. You need microscope. Atoms and molecules are always in motion and are always bumping into one another. And it's a cool information. It says atoms and molecules are in motion. Even atoms and molecules of solid state, right? For example, this piece of actually wood, this piece of wood is a solid, right? Maybe you think about the atoms and molecules and you say they don't move. But in reality, the atoms and molecules of any substance, regardless of its phase, actually are in motion. The particles are in motion, the molecules are in motion, and they bump with one another, they collide each other, and that's it. It says the particles interact with one another. Interact means they collide with one another, they bump each other, they push back each other, right? And the way they interact with each other helps determine the state of matter. It means these motions determine the state of matter. The motion of particles of substance determines what? These motions determine the state of matter, or determines the phase of matter, right? I'm gonna finish the first part of this video. Actually, I want to finish the complement of this lecture for this lesson for the next video. I appreciate you to be with me, and bye for now.